Welcome back. I am Ms. Killen here at MPB. We are still in our Unit 6. This is the last lesson for this Introduction to Quadratics. We are looking at Lesson 9 today, Quadratic Functions in Action. So this is going to be our last lesson in this introduction. We are looking at FIF4. I can write a quadratic function to represent a real-world scenario, and I can interpret key features of the quadratic function in a real-world scenario. So let's just dive right on in. It says, let's see how to work real-world scenarios. So Anna threw her block into the air and watched it fall to the ground. She then drew a graph. Notice the height compared to the time passed. So as I see the block increase in its height, at a certain place, I start seeing the decrease of the height. But as we can see for this x-axis, time is our constant. We always want to make sure that we are reading all the information that we can read in these graphs. 9 times out of 10, if we will read the passage and then look through the graph, we will get all the information that we need for the problem. All right, so let's see. Let's see how to work this real-world scenario. So then we know that Anna threw her block in the air, it fell to the ground, and we've noticed the height compared to the time passed. Now, let's look at some questions about Anna's graph. What was the height from the ground of the block before it was thrown? So when Anna is standing there and she has a block in her hand, what is the height of the block from the ground? So let's look at the graph. If we look right here, this is where my block starts. So I could say it was 3 feet above the ground. All right, then it says, how long does it take for the block to hit the ground? So now we're having to look at that time, which is our x-axis. So it takes it till about 11.5 seconds to hit the ground from when she lets it go. Making sure I'm spelling those right. And then it says, what is the highest the block reached? Now this is where we look at that vertex, that maximum of this parabola. So let's see what this is. So here is my height right here. This is the highest point of this parabola. And we see that it is at 10 feet. So when she throws this block, it goes all the way up to 10 feet before it starts its descent or decreasing in its feet to the ground. So then it says, how long does it take the ball from the max height to land? So let's look at this point. So here is my max height, and about what? Right here, maybe about 5 seconds, it hits the max height. So how long does it take for it to hit the ground? Yes, I would say about maybe 5 to 11, then and a half. I would say about 6.5 seconds maybe. And then what vocabulary do we call the max height of this graph? Now, let's remember back to what we've learned about the parabola and our quadratics. What is that max height, or sometimes that min height, or the minimum of the parabola? What's that called? That very point that it starts either increasing or decreasing and switches the other way. What do we call that? The vertex. So that vocabulary we're looking at is called the vertex. Good job. All right, so let's look at our next problem. It says, let's do some practice. Royal loves to play golf at Live Oaks Golf Club. He hit a ball off the golf tee that has a height shown by the function g of t equals negative 16t squared plus 80t, where g of t is the height of the ball in feet and t is the time in seconds it has been in the air. The graph shows the height of the ball after it was hit. Now, I've read my passage. Now I want to go to my graph to see all the information that my graph can give me. So let's look. I see where my graph starts, and I can see where my graph ends. I'm looking at how it arcs. I'm looking at the top. I see a maximum. and I see how long it takes to go from x-intercept to x-intercept. So now that I can see my elevation in feet and my time in seconds, let's look and answer some questions. How long does it take the ball to reach the max height? So let's see, how long? Here is my max height, about right there. So I would say that's about 60 feet. Now, how long does it take me to get to that 60 feet? So I'm going to just look down here, down here, down here, down here, down here. Well, it takes about 5 seconds. Then it says, what is the max height of the ball? Well, we already determined that. We said that was 60 feet. After 9 seconds, what is the ball's height? So I'm going to go all the way over to 9, and then I'm just going to draw a line up. And then I'm going to draw a straight line over. I'm thinking it's about 30 feet. How long does it take the ball to reach 40 feet after it's hit? So now I'm going to come back over here to 0, 0 and go up to where my parabola is 40 feet. So how long does it take that? It's going to take me about 1 second. So when I read my passage and then I looked at my graph, I was able to answer several questions and get the knowledge before I even got to my questions. So that's why it's so important to look at those graphs, get all the information that you can, and then most of the time it's easier to answer the questions that way. So let's look at some more questions. Now this is a Mississippi Department of Education question. So I want us to read it, look at the graph, read the questions, and then I'm going to let you or your table partner work this. So I'm going to go ahead and read it, and we'll talk about it, then I'm going to let you work it. Lauren is working with her coach to improve her tennis skills. A graph of her latest serve is shown. Which statements are true for the function represented by the graph? My y-axis, I have height in feet. My x-axis, I have time in seconds. And then I have my 7 statements. Go ahead and pause the video and let's see what you or you and your table partner get, and then come back and let's see what we got. Okay, let's see what Lauren's done and let's see what we can answer about Lauren's questions. So now I'm going to read these different statements and see which one of them are true. It says the function increases for all real numbers. Well, when I look at this, I notice that I'm increasing, 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 and then I stop increasing. Then I notice that I start decreasing, 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 decreasing. So I know one is not true. I do not increase for all real numbers. The next one says I decrease for all real numbers. Well, we just said that that's not true either, because I do have a portion of this graph where I do increase. So I know this one's not true. Let's look at number 3. It says the function is increasing on the interval 0, which is less than t, which is less than 8.3. Well, I don't even see 8.3 seconds because it's back to the ground here at almost 1.2 seconds. So I know this one's not true. So let's look at number 4. It says the function is increasing with intervals 0, which is less than t, which is less than 0.38 seconds. So let's see where it increases. So let me get my increase color back. So I do start increasing at 0, and then I go to increase all the way to about right there. So it's not quite 0.4 seconds. So I'm going to say this is true, because it is. Let's look at the next one. The function is increasing on interval 6, which is less than t, which is less than 8.3. Well, my graph doesn't even show 6 seconds, so I know that can't be true. You may see numbers that's on my graph, but we have to read the numbers in the context that we're given and that our graph is given. So I can say that number 5 is not true. Let's look at number 6. So this one is not true. It says the function is decreasing on intervals 0.39, which is less than t, which is less than 0.7.6. So let me get my decreasing color back. So right here, which would be 0.39, and I decrease to about right there, which would be 0.76 for my time. So that one's true. That is an interval of space that I am decreasing. From that time of 0.39, which is after the other interval, to about 0.76, I am decreasing in that time frame. So let's look at number 7. It says the function is decreasing from 0.76 less than t, which is less than 1.1. So if I look here, I start again decreasing, and I decrease till I stop. Well, that's not quite yet at 1.2, so I could say that this one is also true. When I'm reading these intervals on a graph, take them literal from this point to this point. You always want to make sure, just because you see the numbers, you've got to make sure the numbers are relevant to the context that the graph and the problem is giving us. Good, good, good. All right, so let's look. I don't want to forget. I want to make sure that me and you are reading the whole graph and getting all the information that we can. We want to make sure that we understand what the variables are representing in the situation that's being graphed. And I always want to make sure that I go back and check that my answers, and you're checking that your answers are making sense in the passage context. I'm so glad that you came back here to learn with us here at MPB. Thank you, and I want you to have a great day.